In this video, we're going to describe how the mesh current technique will work in order to solve circuits. So the first thing you do is you identify your mesh loops in your circuit, however many there may be. For each mesh loop, you're going to have a variable indicating the current through the loop. And I do want to make a very important point here that the current through the loop is not necessarily the current that is actually indicated in your problem. And you'll see that in the example below. But just point it out right now that whatever currents may already be drawn in there, whatever current you may be seeing through an individual resistor, that is not necessarily what the mesh current is going to be. After we've done that, every time we have a mesh loop, we're going to go around the whole loop there using KVL to write an equation. When you're trying to find the voltage drop across the resistor, you're going to use Ohm's law. In particular, the version of Ohm's law that we're going to use here is V is equal to R times the mesh loop that we are in minus the current in the mesh loop that we are not in. So I loop in minus I loop not in. What we're really doing there is we're trying to find the true current through the resistor. And so you take the current that's going in one direction and you subtract the current going the opposite direction to find the net current through the resistor. That's why we have that there. After we set up our system of equations, we also need to look for any dependent sources, which will give us their own equations. And then once we have all of that there, we go ahead and solve it, and we get our answer. Again, we have a warning similar to the node voltage technique, where if you have a source in a bad place, previously for node voltage, was if you had a voltage source in between two nodes. Now the problem is going to be if you have a current source between two mesh loops, then you would have to use a super loop in order to solve it, which we will see in a later example. So for this one here, we have our circuit here. We're going to have two meshes. We're going to have one on the left and one on the right. Now when you're doing this, you have to decide what orientation you're using. And if you're ever inconsistent about the orientation, it's going to make your life a lot harder trying to figure out passive sign notation or not. So you might as well just make everything clockwise and just stick with always clockwise. Make your life easier. And we're going to go ahead and call this first mesh I1, capital I1, and the second mesh, capital I2. And I do want to point out that the capital I1, in this case, it's whatever current is going through this loop as we go all the way around it. Now in this case here, as we're going around this loop, the current that goes to the 5-volt source, that's capital I1. The current that goes through this resistor is capital I1. So capital I1 and little I1 are actually equal. But as we go down this middle resistor, it's affected by both the current in the left loop and the current in the right loop. And so the net current through them would be I1 minus I2. And so that's why we're going to have to do the V equals R times I1 minus I2 when we do our KVL there. So KVL on the left, coming in the negative side of the voltage source, so negative 5, plus the current here 2, and it's going to be capital I1. And then the middle resistor is going to be plus 8 I1 minus I2. There's our first KVL equation. Then if I look at the right side going clockwise, I see the 4 ohm resistor. Now again, this 4 ohm resistor, it's only in the second loop, so it's only affected by the second loop's current. So it would go ahead and just be 4I2. I'm coming in the negative side of the voltage source there, so minus 3. And then I get to the middle resistor, and you might say, well, I'm going on the negative side, so I should put a negative in front, but then I do the I1 minus I2, and you write passive sign convention, all of that stuff, or just train yourself to it's always going to be plus, not ever minus, always plus, resistance times loop we're in, and I'm currently in loop 2, minus loop we're not in, I1 equals 0. So if you remember, it's always just V equals R times I loop in minus I loop not in. It will all work out with passive sign convention as long as you are consistent clockwise and everything. So just make your life easier and do it this way here. So then I have a system of two equations and two variables. We can simplify these things here. Let's see, 2 and 8 makes 10I1 minus 8I2 equals 5. And then for the second one here, I have minus 8I1 plus, let's say, 12I2 equals 3. Then maybe I'll go ahead and multiply the top one by 1.5. That will then get me 15I1 minus 12I2 is 7.5. Add down gets me 7I1. The I2's cancel is 10.5. And then I1 is 10.5 over 7 is 1.5 amps. So I've got my I1 here, which I can then plug back in to find my I2, capital I2. Maybe I'll plug it in the top one there. 10 times 1 is 15. Minus that's going to be negative 10 divided by negative 8 is going to be 1.25 amps. And once I find my capital I1 and capital I2, I can go ahead and find everything else in the circuit. So as we said, little I1 happened to be the same as capital I1. Little I2 is the difference between capital I1 and capital I2. It's the net current there. So capital I1 minus I2 is going to be 0.25 amps. And capital I2 is the same as little I3 in this case. So we get 1.25 amps. Then if I want to find my three voltages, I just use my Ohm's law at each one of them. 2 times I1 is 3 volts. V2 is 8 times that is going to be 2 volts. And V3 is 4 times that is 5 volts. And this gives us our answer here using mesh current analysis.